Let's say a few words on compulsory task 5. What you should do there is the first step is to interpret a process diagram, and the process diagrams might look a bit scary in the beginning, but take it easy. There are certain symbols like these ones here for a pump, and this small thing there is the engine of the pump. You can have a valve. You can have a valve with a regulator, a rotometer that measures flow rate. You can have different sensors, and as you see in the process diagram we give you, there are a lot of sensors, and that's the way you run a plant. If you have a process that you want to run and you want to run it efficiently, the only way to do that is to have a lot of regulation. And you might have advanced programs to try to simulate the process while it happens, so you can know in advance, okay, now things are going the wrong way here. What do I need to do, and how much should I change this valve so that it works better? This rectangle with the diagonal in, that's a heat exchanger. But there might be other heat exchangers that in the process diagram that are drawn with another symbol. The good thing with the simplified symbol for heat exchangers is that it's very easy to figure out how the flows are connected. If the flows are on the same side of the diagonal, then that's flows that are in the same medium. And on the other side is the other medium. But in other cases, if they don't use that simplified symbol for heat exchanger, you have to figure out yourself how the flows are connected. So you have to use your understanding of the process that is being described and other clues from the process diagram to figure out how this works. So you should interpret a process diagram, and you should make a simplified overview without all these regulators and stuff. Just a few simple things. And when you do heat exchanger there, you should use, you must use this simplified symbol, the rectangle with the diagonal in it, and make sure that you draw the flows appropriately. So flows on the same side of the diagonal are the same medium. Okay, once you have done this simplification, you should calculate heat exchanger areas, the two heat exchangers that you should calculate the area for. And then when you've done that, you should identify and estimate energy reductions. So they have done some clever designs in this setup, and you should try to figure out approximately how much energy have they saved by choosing this clever design and using these heat exchangers in the manner that they do. Okay, so how do you do that? How do you estimate the energy reduction if you only have one thing to look at? Well, look at the design, your simplified overview of the design, and then try to imagine a less good alternative to solve this separation problem. And then compare that less clever solution with this process diagram. In Compulsory Task 5, you should have a proper report, and that report should also have an executive summary. So think of the executive summary here as a very, 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 very short report that goes to someone else. So typically, executive summaries can go to decision makers, and then they only read the executive summary that should contain the things that they need to know. So things like, what is this thing about, and what was our task, and what are the results, and what are the main conclusions. Then the big report typically goes then to people once the decision has been taken to carry out something. Then the thick report goes to people who actually will make this happen, and they need the details. The decision makers typically don't need the nitty-gritty details. They need the overview. And one more thing with Compulsory Task 5. There is a reason this compendium exists. There are exercises in here, examples in the text that go through how you do these calculations, how you estimate overall heat transfer coefficients going from one side to the other. So look in this one, read, and before you start doing the calculations, look in this one carefully.